No. Be lying. He's just a myself.
All right, then. So we'll do question one, and then, like I said, I'll let you guys pick another one. What I wouldn't want to do for the second one that we do together is question two. And the reason is because question two and question one are like totally like the same idea. So what we want to do is question one and then one that doesn't look like question one. So for question one, the goal is here that we have two functions, f of x, which is -5 minus 9/4 of x, and then we have a g of x. And I think they're all f and g. I'm not sure, but yeah, they all are. And then for this function, we have -4/9 of x. And I did ask it to only use x's, FYI. There was a checkbox. There isn't always a checkbox for that, but I was going through this one and it said always use x as variable, and I was like, yes, please. And I checked it, so you're welcome. So do you guys remember how to use composition to verify if or if not functions are inverses of each other? So we do f of g of x. And what are we watching for? Hmm. It equals something, but not one. Nope. Let's work. No. Nice try. Let's give it a shot, and then we'll see if maybe it comes back to us. And don't spend all your time thinking about it. I want you focusing on the process. What did you just say? It is. Good job. So if f of g of x comes out to equal x, and when we compose the other direction, if g of f of x also equals x, then we can say that the functions are inverses. So way to go. I wasn't expecting it to just come out of nowhere. Good job there. So let's do the composition one way and then we'll do it the other way. And it's really, there's a lot of good stuff. Like it looks like a fraction nightmare, but really these aren't too bad because a lot of things cancel out. So the trick, remember, we practiced this yesterday and the day before, is when we do compositions to take the outside function f and write it down. But when you get to the part that says x, you leave an awkward void. So we're going to do -5 minus 9/4 parentheses awkward void. And what's going to go into the void? Nice. So -4/9 of x minus 20/9. And again, it looks pretty fractiony, but really at the end of the day, there's a lot of good things that are just naturally going to happen. So things are going to cancel nicely. So the -5 just has to wait his turn, and we're going to take this -9/4 and we're going to distribute it through. Don't have to, but honestly, it works really nice. You could kill it, but then just trust me, everything works real nice if we just do it this way. So what's going to be what nice thing happens in that first little yellow distribution there? Yeah, they're like reciprocals, they're gone. So we're left with -5 plus x, because the 9/4 and the 4/9 are perfect canceling reciprocals. And then when the -9/4, this I might need to show a little bit more work on this one, but when the -9/4 and the 20/9 multiply, I'll go off here to the side. Right. So what happens is when all's said and done, the 9s cancel, and then the 20 and the 4 are survivors, but 20 divided by 4 is 5. So, and if you can do that kind of stuff in your head, like, please, by all means, that's what you should be doing. But if not, show it. So these, I don't know if it's a half and half split. I think there's more yeses on this worksheet than nos. I don't really remember exact, but I feel like it's a slightly heavier lean towards yes. But we're only halfway done with this problem because when the -5s and the 5s cancel, we are left with success. But remember, it's only a partial success because we have to then verify the other way as well. So f of g is like, all right, victory. And now because it worked, the bad news is we have to keep going. So now we're going to go the other direction and we're going to do g of f of x. And the trick, again, it's really not a trick, it's to write the function named g and then leave awkward voids where the variable is, the input slot. So this one's going to be -4/9 times awkward void minus 20 ninths, like that. Good. And what's going to go in the void?
The other problem.
Yeah, the other function, right? So -5 minus 9/4 of x is going to go in there. So -5 minus 9/4 of x. And again, just kind of ride it out. Things will happen. It's kind of a basic skills nightmare, maybe, but really nothing terrible. So let's again do distribution. What's the answer to this first distribution right here? Positive 29ths. Good job. So we get 20 over 9. And then the second yellow distribution is all the way across. What do we get? Again, plus x. That worked out nicely yet again. And then we copy down the minus 29ths at the back. That whole process feels pretty smooth, and it's going to kind of feel largely like that as you go through all 12 of these problems. Like there's not a lot of like real ugly-ish sort of non-compatible fraction-y things going on. So, but these are nice. Like you can just feel kind of the vibe and the flow of it, that it's going to work. So the 29ths kill each other out, and we're left with x, and we have another success. So our answer to this one is just simply, yeah, they're inverses. Okay. You want to, let's do number 3. 3 looks a little different, huh? Or you guys pick. Anything else? 3's fine. 3's fine. Yeah. So on 3, we have a function, and whoever's watching this video, if they are, they'll have a copy of the worksheet because I'll have it on Canvas. So I'm not going to copy the problem down. That's a waste of time. So what I will do is just get right in and get going. So our first composition, I like to do f of g first. You don't have to. So I'm going to put this. I'm going to write 5 awkward void plus 10 divided by 2. And into the awkward void, I put the other function g of x. And so x plus 2 over 6. Yeah, it's a fraction inside of a fraction, which is pretty kind of weird, right? It's not the end of the world, but it sure would feel nice if something would just go ahead and cancel out for us. But it's not in the cards for this one. So what do we do?
Distribute.
Yeah, just distribute, suck it up, get it done. Like trying to kill fractions here is pointless because the fractions, as they have been throughout this, they hide from us in the parentheses. So we just got to deal with them. So what is the answer to this first part right here?
5x.
If we just multiply the whole thing by 5, we get 5x plus 10 over 6. Everybody okay with that? Okay, so when you multiply that little part like that, the 5 multiplies by all of the stuff in this yellow box. Because remember, 5 is like a 5 over 1. And when you multiply by 5 over 1, the 5 only multiplies to the top. That's a pretty common mistake because people like hit it to the bottom. We don't do that. So we're going to wind up with 5x plus 10 over 6 plus 10. And then all of that is over 2. Good. What do we do now? Yeah, I guess you could.
You want all the bottoms in your saying?
Yeah, I mean, I'll give you my advice. Since they're paying me to be here, I might as well tell you my 2 cents and you can take it or leave it. My 2 cents is ignore the bottom. Whenever I work with fractions like this, I prefer to make the top the best version of itself that it can be and the bottom the best version of itself. So I look at it as let's just ignore the 2 and let's just focus all of our energies on the top and make it as clean as we can. Yeah, but I guess that kind of feels we have to make a common denominator. Do you guys know that? This isn't an equation, right? So I think to be clear, we want to turn this into a fraction that looks like this. So what do we do?
6.
Right. So we want to write that 10 as 60 over 6. And now that the bottoms are the same, what do we get?
5x plus 70.
5x plus 70 all over 6 all over 2. And I feel like at this point, the top is the best version of himself. Like he's not going to get any prettier than that because, you've got just a fraction. So this is a good time to copy, kind of think of it as copy dot flop. So you'll remember this kind of a blast from the past that when we divide by two, if you kind of picture it, it's a little cosmic and weird. But when you have a whole thing, a fraction divided by two, you kind of take that two out and flip it over while you're bringing it out and then multiply. Which I guess what I'm trying to say in a very clumsy way is that this fraction becomes 5x plus 70 over 12. You see that? How that worked? Dividing by 2 really just means to multiply the bottom of the fraction by 2. And I don't see anything good coming of this. Like, can you kind of see the writing on the wall? Is this going to come out to be x?
No.
No way. Like, no way. Like, that ship kind of sailed probably 30 seconds ago. Like, we're just looking at it going, this isn't going to work. So you try to divide everything by 12. Nothing good's going to happen. You could stop at this point in time and say no. And what's the good news, though? You don't have to do the next one because if f of g doesn't work, I really don't give a rip if g of x does or g of f. So is that good enough or would you like to do another one together? Because I don't mind. Number 4? Sure.
4 is weird.
4 is weird, huh? Okay, let's look at number 4. So let's do f of g of x first. So that's going to be 2 over awkward void minus 3. Got it? And then in the awkward void, we're going to put 2 over x plus 3. And it turns out those parentheses actually are not necessary, right? Generally, I just put them there, but in a case like this, since there's nothing multiplying in the front, I can just omit the parentheses. Don't need them. Like I said, remember, if you take any advice from me today, you should take what I said a couple minutes ago, and that is when you're working with complex fractions like this, work with the top as much as you can, work with the bottom as much as you can. Don't let the top and the bottom interact until they're as pretty as they can be. So the bottom, there's a real gold mine here. There's something huge. What is it? Yeah, take your 3's. Plus 3 and minus 3 are gone. And then we're left with a pretty simple scenario where we have 2 over x. And like I said, well, we can't, because these aren't equations, so we don't just get to go multiplying things like whenever we want. What I'm saying to you, and I wish I could like animate this for you, is to take this 2x out off to the side. But when you bring it off to the side, you should flip it over. That's that kind of copy dot flop mentality. If I wrote this out longhand, it would look like this: 2 divided by 2 over x. And copy dot flop says that we should take the 2 over 1, leave it, change this to times, and write this as x over 2. I don't know if that's any less clumsy than what I was trying to say before. But bottom line is that when it comes out, it flips over, it becomes x over 2. The 2's cancel, and our answer is x. Got it? Okay, let's go the other way. So the other direction is to do g of f of x. So for g of f of x, we are going to do 2 over blank space plus 3. No need for parentheses this time because there's really like nothing going on with it. It's just like an empty space. So in that space where it used to say x, I'm going to put another fraction, which is 2 over x minus 3. So again, what you're working with here are called complex fractions, where when there's a fraction inside of another fraction, we call it a complex fraction. We try to get common fractions where there's no weird stuff inside. That's the goal. So what do you think? What do we do?
Copy.
Yeah. Again, there's no cleaning to do. There is this. There is that I need to do 2 divided by the purple circle. And how do we divide by the purple circle? We multiply it by the reciprocal. So the 2 that I'm going to circle in red looks like this. The purple circle, since it's a divisor, I flip it over and I change this to multiplication, and the x minus 3 goes to the top and the 2 goes to the bottom. And then the plus 3 just gets copied over. Good. From here, it just all sort of falls to pieces. I mean, in a good way, like it just crumbles, right? All the things getting in our way just fall apart. What's the first one to fall? The 2's got to go first. So that's a 2 and a 2 that die. And then I'm left with an x, a minus 3, and a plus 3. And now I can legally get rid of the minus 3 and the plus 3. And I get x. So that's the format that you can expect when you have to take your test, whenever that is. So that's why I gave you a bunch of these to practice today. You guys good? I'll leave the recording alive. Like I won't end it and all that. I'll just pause it. And if you guys are like, hey, can we go over this or this? Then I'll just bring it back on. Sound good? Cool. So I'm just going to go with what Bryn did because she did top bottom. So I know I keep saying I do f of g first, but honestly, I'm just going to do top of bottom. So the first one I'm going to do, so this is number 7. And the first one I'm going to do is g of f, only because it just is the order that the problem's in. So this is a little bit tricky because when I write it out, I get 3 over something plus 3. And I don't feel like I need to put parentheses there, but you can if you want to. So this is what it looks like in its like ready to be fed form. And then what we're going to feed in there is the other function f of x. And the other function is, I hope I didn't answer your question incorrectly when you said, can I cancel out the 3's? Because maybe I was thinking of the different 3's. So sorry if I misunderstood. But I'm going to put in here the other function, which is 3 over x minus 1 minus 3. And yeah, honestly, I wish I hadn't even re-recorded because all this stuff I was saying about this being harder was a big fat lie. I think I misread something. Was you have something weird on? Did you? I think that's what it was. So that's why I was inspired to waste your time with this conversation, because the fact, so Bryn, sorry to use your name on the recording, but it's never stopped me before. Bryn didn't have that minus 3. So I just want to show you something real quick that would have happened here. But anyways, this is very anticlimactic because with the minus 3 there, those 3's cancel and the problem's real easy. But anyways, if you're still interested, if this minus 3 had not been here, here's the trick that you'd have to know how to do. In order to make this 3, right, I'll make it well, the white one. The white 3 is a big problem. So what I need to do is I need to make it have the same bottom as the yellow fraction. And in order to do that, I need to multiply it by this. I need to multiply it by something. Hey, if you guys don't want to listen over there, that's fine, but don't talk over me, okay? I'll be done soon, I promise, and then you guys can get back to doing what you're doing. So what we have to do is actually multiply it by this. I'm going to use green. We have to multiply it by x minus 1 over x minus 1. Like that. You would agree that that's legal, right? Because what really did I multiply by? 1. Right, and that's legal. I don't have to be in an equation to multiply something by 1. That's all. We've been doing that since 4th grade when we find common denominators. So then this math problem right here, the white and green one becomes 3x minus 3 over x minus 1. So if this comes up again, you guys that are paying attention, you're going to know what to do, because now what I'm going to do is I'm going to replace this right here with this. And you see now that the bottom can be done, can't it? Because we made the bottoms the same. You still with me? So if we put these together now, we have, I'm going to draw a purple sort of bubbly shape around a really important part. We can do all of that purple problem together and then just put it all over x minus 1, right? So what is the answer to the purple monster thing there? What is that? It's just 3x, right? Because the 3's, this one, and this minus 3 cancel. So we're left with the problem looking like this. 3 over 3x over x minus 1. plus 1. So this is what the explanation that I thought was going to be necessary based on what I saw. But if it were to happen again, then know that that's how you need to navigate those waters. And so now we're just back into copy.plot mode. And it's pretty clear that this isn't going to work, but let's give it a shot anyway. So we wind up with 3 over 1 times x minus 1 over 3x. At this point now, it's a random problem because this is a hypothetical if what she had on her paper was actually what was supposed to be there. But it's a good conversation to get to have anyways, because this will eventually happen. So it's good. So at this point, the 3's wind up canceling and we're left with x minus 1 over x plus 1. Are you still with me? And then I can't add these together yet. Why not? The x's don't cancel, and I had a picture on my board last year that you might remember.
That happened.
Here it is. Do you guys remember the kitties? Every time you do this, a kitten dies. Do you remember this from Algebra 2? Was this on the board for you guys? Do you remember this?
Yeah.
Use your wallpaper.
It was my wallpaper. You're not kidding. So the point is, remember that if something's part of an addition problem, you're not allowed to cancel it out. So these x's up here cannot cancel each other out. So what we'd want to do is multiply this 1 by x over x to turn it into the same thing. And now you can add these together because the denominators are the same. So we wind up with, finally, if you add, I'll do purple guy again. So if you add all the things in purple guy, what do you get? 2x minus 1 over x, which is not equal to x. Problem over. So you can see one little slip of the pencil can cause an infinitely more complex situation. But in this case, that's enough for us to look at it and say that doesn't equal x. So got it? Back to work then. So sorry, number 7 turns out to be actually pretty simple.
If you do it actually, it's really easy.
Yeah. So.
No.